Need your devices to run smoothly without tripping over each other? Let's dive into the magic of parallel circuits. Imagine a multi-lane highway, each lane representing a different path for cars to travel. That's how a parallel circuit works. Each lane or branch lets current flow independently, ensuring your gadgets get the full voltage they need. In a series circuit, adding more resistors is like adding more toll booths. The more toll booths, the more your car has to stop, slowing everything down. But in a parallel circuit, adding more branches is like opening more lanes on that highway, letting more cars flow freely. So let's tackle a real-life example. You've got 3 resistors, 10 ohms, 20 ohms and 30 ohms, connected to a 12-volt battery. First, calculate the reciprocal of each resistance, 1/10, 1/20 and 1/30. Add them up, that's 0.1 plus 0.05 plus 0.0333. The total is 0.1833. Now take the reciprocal of that sum, about 5.45 ohms. That's the total resistance. Now to find the current through each branch, use Ohm's law I = VR. For the 10 ohm resistor, it's 12 volts divided by 10 ohms, which equals 1.2 amps. Do the same for the 20 ohm, 0.6 amps, and 30 ohm, 0.4 amps resistors. So remember, parallel circuits are your multi-lane highways, keeping the current flowing smoothly and efficiently.